next presentation. At this time, I'd like to introduce Brett Connell, our next speaker. He is a key developer of the high definition stream survey methodology and a founder of Trutta Environmental Solutions. He has 20 years experience in water resources, stream ecology, and fisheries biology with project experience across the U.S. So please welcome Brett.
I appreciate it. Thank you. And so with that, I'll go ahead and advance the first slide to kind of get into my history. As you said, a lot of my early career experiences in fisheries. I'm sure like many of you in here, stretching the tape across the river, taking measurements, doing pebble counts, and spending a whole lot of time in one little area. And then you extrapolate that data from miles upstream and downstream, and I could never stand it. It was not representative of what was actually going on upstream, and so I always thought that better could be done. And then obviously GIS, there's tons of advancements going on with that, and it's very useful. But sometimes the QA/QC needs to be done, and the level of resolution with that data isn't always the best. And so that's why we created the high definition stream survey. And so back in grad school, which I'll touch on here in a minute, I'll get into that. But just being able to do a continuous survey, being able to collect 20 miles of river in a day and turn it into meter resolution data is what was the goal. And then when you see this watershed as a whole with meter resolution, you're able to make better decisions. The more data you have, the better decisions you can make. And so here's me back in grad school with my advisor. Back then we just had left and right video cameras with a depth sensor and a GPS unit. And we did a continuous bank erosion hazard index as we went down the river. That's been peer reviewed, published. And then I literally turned my thesis into a company in 2012. Since then we've added forward video, we have downward video. I literally just did an eelgrass mapping survey down in Florida. And so whenever underwater video doesn't work because of depth or turbidity, we have a side scan sonar unit that's getting depth side scan. And I'll touch on it a little bit, but AI is obviously a big buzzword that everybody's using, but we're doing machine learning with both the video imagery of the shoreline, and then also there's already programs where you can use machine learning and AI programs to do automatic delineation of substrate types using the Hummingbird side scan sonar data. On top of that, we have an ADCP we can run, which is an acoustic Doppler current profiler. A lot of the work we do is below hydroelectric dams for FERC relicensing, and so we can get discharge measurements at any increment or wherever discharge measurements are needed. We're always running a water quality sensor. Usually we always run the standard 5, like DO, pH, turbidity, specific conductivity, and then obviously we're not beholden to any type of equipment. If there's a different type of sensor that is focused specifically on heavy metals or different types of AML type measurements, we can take that water quality sensor out wherever it needs. We can also do water grab samples, sediment samples, and then eDNA, environmental DNA samples, if anybody's familiar with that. Again, the whole point of this is just rely on the technology. We have micro SD cards and lithium ion batteries. I can turn on equipment, literally surveyed 9 straight hours, 18 miles of river recently, and have meter resolution data of that entire stream just because I let the data collect, or I let the equipment collect all the data. And so Hurricane Creek is a project you're going to hear about. This is actual video that we took back in May of 2023. And so a lot of times I put on video webinars, and I'll be down in Florida, and I'll be talking to BLM up in Alaska or somewhere over in the upper Delaware River watershed, which we've surveyed before. Having this video archive, we're all taking a tour of Hurricane Creek right now. We're seeing what left bank condition, right bank conditions, substrate. The depth data right here, the depth data doesn't really show up because the water is less than 14 inches. Whenever it's shallow water, you don't get the greatest side scan imagery. But then you can see riffles coming up, so you're getting habitat type, full riffle run sequence. Most of the work we've done is by kayak. We've mapped over 1,400 miles of river for every level of government across the U.S. for numerous different types of water resource issues. A lot of the stormwater work we do involves backpack work, East Maui irrigation. The list kind of goes on. We've done a lot of dry stream beds, and then I've also had that raft 40,000 CFS flows below, like on the Coosa River in Alabama. And so the whole point is doing ridge to reef, and so there's no body of water too big or too small that we can't run this system on. And then there's also additional forms if we're running into hazardous areas or property lines that we can't get past. whether we bring in tablets, drones, or autonomous boats will come in handy. There's a lot of impoundments, especially on mining lands, and being able to determine, how deep is that pond, or is that pond as deep now as it was 20 years ago? Is it still functioning? And so again, just utilizing all the technology to collect as much information as possible. The more data you have, the better decisions you're going to be able to make. And so this right here is the Hurricane Creek watershed. This is Tuscaloosa, Alabama, right here on the Black Warrior River. And so they, obviously, just like Pennsylvania, they have a lot of pads already predetermined, but they didn't really have a way to prioritize which pads were the worst, or even, which tributaries or sections of river within the pads were the worst. And so they wanted a way to, one, prioritize the pads, but then also just look at the watershed as a whole. And so this is the work. We had 2 to 3 different crews every single day running for 3.5 weeks. We mapped 250 miles of the river continuously. Some of the red segments you see are actually where we sent out a mailer beforehand, and when property owners said, don't come on my property, we just marked off that little tributary and then we didn't go to it. The purple ones, I believe, are dry tributaries that didn't have any water going in it. And then what we traditionally run is the stream corridor assessment. This is based on like the Maryland stream protocol assessment, I forget, but we're not beholden to any type of index either. If Pennsylvania has a specific type of information or data format that you need the information in, we can deliver that. And it has 4 main parts: the riparian, the stream bank, the stream bed, and then also discrete features throughout the watershed, which I'll get into each one of these in a little bit. And so after we go and do a survey, we'll combine the left video, right, forward, down. We'll combine that into what we call Trutta Stream View, and then we can put it in this program. And as I'm watching this, you have point events such as like outfalls, trash, cows, acid mine drainage. The list kind of goes on the different types of points, and I'll say, so I'll hit A for an exposed pipe, and then it'll stop, and I'll say, is it affecting the left or the right bank, or both banks, or just the stream bed? And then it'll start compiling at what frame of video, at what time in the video did that event happen. And because each second of video is geo-referenced, I know the exact GPS location of all these different points. And so we'll do that for point events, and then we'll also do it for continuous. And so bank condition, for instance, I'll be watching the left bank, and I say this is a 1 or a 2. It's good, it's not non-functional. But then when you get up here into the very cut bank, that stream bank isn't functioning very well, and so that can be a 5. And then we'll just continuously populate all these GPS points, and so then you'll see like the track log, it's a GPS point that has information on both left banks, both riparians, and then the stream bed. And then you also have all the point information. So these would be your fish barriers, trash, invasive plant species if needed. The list kind of goes on. And this is a stormwater project we did for the city of Cleveland, Tennessee, where we actually took all of this information and we showed them where within their MS4 where can you spend the least amount of money on restoration and get the biggest bang for your buck as far as ecological lift. And if there's any questions at any point, feel free to stop me. You don't have to wait till the end. And so back to Hurricane Creek, this is all 250 miles showing the stream corridor assessment data, both riparian, both stream bank, and the stream bed. Just zooming in on one little area that has a whole lot of red, and again, the database matches the video. And you can just go ahead and take a tour, and you can see like why did this area score so bad. You can see it's been having stormwater impacts for years. It's very incised. You'll start seeing riprap from past times that they've been trying to do, prevent it from eroding any further. You can see exposed infrastructure. And again, we went out and did this survey. It was funded by AMR. I guess I needed to touch on that beforehand, the Abandoned Mine Economic Revitalization. But even though we're out there searching for AMD, we're finding everything. There's stormwater impacts, silviculture impacts, littering, just kind of like, you'll see everything. I have highlights coming up. And so you can, because it's GIS, you can look at this data. It's a very, very, very robust and in-depth data set. And so you can look at it, the watershed as a whole. Here's all the riparian scores, all the stream bank scores, all the substrate scores, and it's a lot to take in. But you can start breaking it up into sub-watersheds. Then you can break it up into the individual pads that they already have determined, and we can start comparing, how does the riparian condition compare, how does the stream bank, the stream bed. And then another metric that we were looking at is just the presence of the oxidized or the iron oxidizing bacteria. Was it was there no effect, was there intermediate, and was there bad? It was literally just three categories. It's another metric that they kind of wanted to have added to the analysis. And so zooming in, you can see there was plenty of no impact, plenty of intermediate, and then the red is obviously what they're looking for. And we can go ahead and take a tour. And so we have this baseline video archive, May 2023, of this entire watershed, and we know what everything looked like when. And then we also will touch into all the different types of water quality sampling that we did during this survey. So in addition to the continuous, or while we're doing the continuous, there's additional points that we're able to see. And so you can look at them all very broadly, but then you can start breaking them up into categories. And so there's, outfalls, trash. We'll look at infrastructure first, all the different types of bridges, culverts, dams. And if we did come up to a culvert or an old road that was non-functional, now we have that geo-reference, and we know that this road probably hasn't been driven on since 1977, and it's been eroding at every single high water event, and dumping tons of sediment into the main channel of the Hurricane Creek, which they're obviously trying to improve. And so this area got flagged. And so that's just looking at infrastructure on one little tributary. And then we can look at trash. So again, because we're going out there, we're looking for AMD for this project, but we document everything. And so there's watershed groups that, sometimes they might need to do a full-on stream bank restoration to protect infrastructure. Sometimes they might just need to know where's poor riparian. So, volunteer groups can go put in willow stakes, or maybe some, Boy Scouts want to go and pick up trash. And so literally we can tell them where exactly to go in this whole watershed to go pick up trash and have the biggest amount of impact with the least amount of effort. But then also this is probably going to take some level of law enforcement to prevent future dumping, because it looks like it's an active dump site. The water quality measurement that we're taking, so again, temp, pH, DO, conductivity, turbidity. And as I'm walking upriver, you can see I'll take a measurement in the tributary, then one upstream in the main stem, and then I just keep on walking, and I take all these little tributaries, and I just work my way up. And then we had other teams that would go and start at that tributary, work their way up, and do the same thing. And so we just spiderweb throughout the entire watershed. And then looking at that data, so there's 240 major confluences that we planned on doing this, and then we also saw additional points of interest. And so if there was an acid mine drainage seep coming in the middle of the stream, we could literally stop downstream, get a water quality sample, document the point of interest, and then go upstream and take another water quality sample upstream. So we're actually able to show, how big of an impact was this individual seep having on the tributary. And you can start prioritizing every single one of these points of interest. And so there was a lot of beautiful water in Hurricane Creek. There was a lot of acid mine drainage in Hurricane Creek. And then there's just a visual representation of all the different water quality samples, and most of them were right around 7. But then there's obviously the low range of 3.17 to 4.5 is the dark red. And so right here you can see that pad looks pretty bad. Most of the pads do have higher pH in general compared to the rest of the watershed. And so that's one way to look at all of this data, is just looking at pH. And so this right here, these are some new maps that we literally just turned in this report on Monday. And so I am hoping that we'll have sample data sets that we can share to other people that work in GIS and want to see how this data could be used. And so this is just the stream corridor assessment. So how functional is the riparian, is the stream bed, is the stream banks. And this is kind of showing they wanted to see the top 20 worst areas of all these different parameters, and then the top 20 of all those parameters combined. And so just right here is the stream corridor functionality. Then right here is all the point information. And so these will be your failed culverts, your stormwater outfalls that are dumping in, acid mine drainage seeps that had very poor pH. And then you keep on going. And so here, this is just all the little catchments based on, and this is the stream bed color. So again, no AMD or intermediate or really bad. And then right here is just the pH ranking of all the worst pH. And so you have color, pH, and then you have stream corridor, and then point assessment. And then they want the Department of Labor, they're the ones who distribute the AMLIF funds in Alabama. And so they wanted to basically combine those 4 equal weight to determine, okay, these are the areas that we need to focus our efforts on. And so now they have there's kind of multiple purposes that this data is going to be used for. is there's obviously years and years of past reclamation. There's no active AMD treatment in the watershed that we went by. It was all passive, but they'll be able to kind of look at passive methods, which ones were more effective than others, and so they can look at past work. They have baseline documentation of May 2023, and so they can prioritize future decisions, future reclamation. And with this data, they're going to do that. And so more projects are going to go in the next few years, and then we're actually going to be going back in 10 years and redo this survey. And we'll be able to show with meter resolution where are tributaries, where's water quality, where's everything improving or declining. And so it's like if we're spending X amount of dollars, we should expect some sort of return. We need a return on investment for all this money that's being spent. And the way that we monitor just really puts an ROI on, those results, being able to track and make sure that the actions we're taking are being beneficial. A lot of the work I do, like we're involved with dam removal, we're involved with stream bank restoration, and it's mind-blowing when I go to some of these conferences and I see like the millions and millions of dollars that's doing this good work, and they think it's doing good, but there's just zero monitoring involved, and so they don't actually know, like, is ecological lift improving, is water quality improving, or is it just look pretty? And so it's either way. Things are changing, and especially it seems like here at these conferences that monitoring is starting to become a bigger picture. I know with dam removal especially, the Corps of Engineers is starting to require a more robust monitoring program when it comes to dam removal and making sure that actions they're doing are actually beneficial. And so with this project, we knocked out the 250 miles in May of 2023, created that 1 meter resolution baseline inventory, identified old, prioritized new, and then it wasn't just AMD and AML type issues that we saw. We documented stormwater, there's sedimentation from silviculture, there's just a whole bunch of other stuff going on, and depending on, the watershed as a whole, if they need to use AML funding for specific AML, they can do that, but then there's other stormwater grants and whatnot that can be used to start funding projects throughout that watershed. And just to kind of touch on the deliverables, you obviously get the Trutta Stream View video, and then you have the shapefile, whether you're using a QGIS or ArcGIS, it doesn't really matter. We're able to deliver in the format that you all need. And then you obviously have the report. And I just kind of touch on, I say how we went out and did this survey for AMD, but it applies to all this other stuff. We've been doing work for, we go and do a high definition stream survey, and especially that's what I love talking to the Department of Environmental Protection here in Pennsylvania, is like you have all these divisions and we can go and do a big survey. That same data set could be applied to stormwater, it can be applied to infrastructure with DOT, water quantity, water quality, fisheries and wildlife. That's, again, my whole history is fisheries, and so in that whole Hurricane Creek watershed, I can just do a query and tell you, like, where's the most suitable habitat for a certain species of frog or a certain species of crayfish or a mussel or a dart or a smallmouth bass. And so it's very easy to do species habitat suitability and then even life stages for each one of those species. We do a lot of work with Trout Unlimited, so sometimes they need to know where spawning habitat is versus, young rearing versus adult. The life stages change throughout the year. And so the other big part of what I really love about what we do is, one, there's a lot of management decisions that are made on what I consider incomplete data. And so one, we deliver this very complete data set, and management now, that they don't typically go out into the field, we can put them in the field. They can actually see what conditions are going on where for the decisions that they're making. And then again, it's red, yellow, green, very easy to understand what's good, what's bad, put them in the river. And the same thing with stakeholders, because there's a lot of people that care about the environment, that want to get involved, but they might not have 20 years of fisheries experience and all the other experience that you would have throughout this room. And so just being able to make them understand what's good, what's bad, and where, and then put them in the river so they can really understand. It's just very communicative and very thorough. And so with that, I do have additional slides. I have no idea where I am on time, but I have plenty of time. Are there any questions right off the bat? Go ahead.
You picked May for that study. Is that on purpose, or is that just a random time of month? Does it matter what time of year?
Well, I've surveyed every month of the year. Sometimes, sometimes stormwater, they want to do leaf off survey, and so they'll wait. Like I've done a survey in December just to make sure there's no vegetation, so you can see bare soil on the shoreline. So flow levels, like we're always watching weather and watching flow gauges, watching discharge from hydroelectric power, and so the list kind of goes on. But yeah, we've surveyed year round, and it kind of just depends on what issue are we addressing and what questions are being answered. Here's the question.
Did you train them in one 3D vision train models?
We've done topo bathymetry surveys. I've put a LiDAR on my boat and done shoreline scanning when we helped locate where to install a drinking water intake on the Duck River for Maui County up in Tennessee. And so no, we do plenty of topography work. When needed, we will go above. We'll connect it to the ground survey and then other control points as needed. Just it all depends on the level of precision that's needed.
And then with leaf cover, technology's great for work, but when we're
Sure.
in narrow canyons.
Well, high cliff walls, all that. It's again, it all depends on what level of precision is needed. This work we did in Hurricane Creek, we didn't need to be within a golf ball precision. Like we're hiking through trees, we have dense canopy, there's valleys. We had a very we upgraded our GPS and had them on our backpacks for all the work, but again, it wasn't survey grade, and we're not getting signed off by a PE. If we do need to, we'll just go ahead and rent the latest and greatest Trimble, connect it to our equipment, and go do a survey. And if we need to stop and hold still, it can slow us down when high level of precision is needed. Especially like when we're doing discharge measurements with the ADCP, we'll definitely, like those are usually bigger river channels, so you only have bad GPS right by the shoreline, but as long as you're in the middle, you get a fixed surface water elevation point that's very high confidence, and then you can drag that to each shoreline going back and forth a few times. Go ahead. Most of it's on the water. We have not done anything like that yet. But we've done plenty of hyperrheic flows, the surface water, groundwater exchange, and so whether we're using water quality sensors or the acoustic Doppler current profiler to see, is additional water coming into the channel from underground or is it disappearing? And so we've done gaining and losing reaches before, but no, and then even with side scan sonar, you get a hardness level, and so if you're going through very soft sediment bottom, it'll penetrate that stuff compared to just a straight up bedrock where it'll instantly bounce off. So you get some measure of that, but even then, we do not do that too often, but we have the capability.
So, we get the sewer level video, but having, word rate video where you went outside, the floor and the bottom, advantageous to be able to assess the whole wall of the culvert.
And so, I have done one stormwater project. I hiked, or I'd say crouched for a quarter mile underneath an airport. So we have gone underground in tunnels and brought lights with us and done that. So is it a culvert that I would fit in?
Yeah.
Sweet. Yeah. Yes, we can do it.
It does vary in places. So some places you probably be able to stand, some places you crouch, some places you need to be able to get.
100%. No, we have additional lighting for that. I'm sorry. I thought this was much smaller than either way. I didn't understand what.
This is, 6 by 5 or 6.
And I could find some short grad students too. I'm sure. I'm not too comfortable in tiny areas, but either way, you got to get the job done. And even Hurricane Creek, you saw that watershed. We went underneath the highway on numerous of those segments, and so as long as one of the techs crawled through one under the highway, we don't need to do that anymore. That's either way. And then so some other, if you guys want, I'll keep going. I have some additional stuff if you guys want. I was kind of touching on habitat suitability, and there's always questions involved when it comes to wildlife. And this is kind of my background. I don't know how many people deal with wildlife on the regular, but there's questions as far as, and hellbender is actually very relevant up here and in West Virginia, but you want to know where are they, what areas do you want to protect, where do you restore, and where do you reintroduce, and all those kind of with our data set, you can answer all 4 of those questions, and all those are not answered the same way. And I was talking about different life stages. The work I did on the Upper Delaware River, that was funded by Friends of the Upper Delaware River and Trout Unlimited. And with our data, we literally showed, brown trout adult, brown trout juvenile, brown trout spawning, different life stages for these individual species. And so we do a lot of work with Trout Unlimited already, but then even just being able to show that on a map. We did the Chattahoochee River for the National for the National Park Service, but it's a National River Recreation Area, NRA. And so when they go and build, they needed to know what types of recreation can you do where. And so I knew, well, this type of habitat is suitable for kayaks that first graders could go down. But then there's also like class 3 and 4 rapids that second graders do not need to go down in a kayak. And then there's also plenty of boat ramps and dammed up areas where different types of, there's boat anglers, there's shoreline anglers, wading anglers. And so prioritizing what types of recreation you can do where, the National Park Service was able to build the appropriate types of access points for those areas of recreation. And then, just kind of looking at everything as a whole. Like, this is 155 miles of the Duck River that we did. And then you can start looking at, you have surface water elevation throughout that whole drainage, and then you also have substrate elevation. Then you can start working with, when you're starting to model drought and starting to model floods, and actually knowing how does habitat for certain animals start changing at drought level. Like, do certain cities need to stop pulling out so much water to help make sure that the teenies species have enough water in there? And so it's used for multiple different types of work. And then this is probably one of the most interesting. This is Upper Delaware River. Can anybody identify that white plant? Japanese knotweed. And so we went out there and did that work, and that was all trout work and habitat work for stream restoration. I did not know what that plant was when we did the survey. And so we did the survey, we're back in the lab. I'm watching, in fact, we already finished watching the video, and the director calls us up. And he's like, hey, can you guys do presence absence of Japanese knotweed? And so we didn't have to go back out into the field. Didn't have to do anything. I literally just watched the video one more time, and I was able to do yes, no. On each shoreline was Japanese knotweed presence. And so we have, throughout that whole watershed, the whole survey that we did in the Upper Delaware River, is it there, is it not? And then because it's GIS, now we have all the actual data of, meters, density, all that throughout the entire watershed. Because they have a whole bunch of different types of controls that they're doing, whether it's chemical control, mechanical, or biological. There's no perfect way to get rid of Japanese knotweed, but now we have baseline conditions. I think we did the survey in, July or June of 2020 during the COVID lockdown, and that was a mess trying to do work in New York, man. But did the survey, and here we go. When we go back in 10 years, we'll be able to show, what types of Japanese knotweed control are being more effective than others. Where is it increasing? Where is it decreasing? And that should be the last slide I got. So had to throw in some extra stuff. Go ahead, Bobby. To the shad? I've never had time to fish. I have four, actually, on the Upper Delaware we had 5 cameras. We had, because we're doing underwater video as well, but then side scan sonar, water quality, GPS. Sometimes when GPS, loses connection with the cell phone tower, it doesn't just automatically reconnect, which absolutely blows my mind. So I'm just constantly watching all these different electrical systems working, because the second one of them doesn't work and I finish a survey, I get to redo it. And so I do not like to redo surveys. It's fun when everything's working, but when water quality starts malfunctioning, or there's so many different systems can go wrong. So it's not perfect, but I'm busy watching, dodging rocks, dodging fishermen, poison ivy. Oh man. And I don't know if is anybody here allergic to poison ivy? Did I hear you were, Bobby? So before I had, again, 8 people working with me doing this work for 3.5 weeks, getting in and out of my truck. I was terrified of them dragging it in because I'm pretty careful with it. But before we got out of once we got out of the truck, I'd spray everybody's hands and feet. I'd fill up a bottle with water and then Dawn dish soap, a healthy dose of it. And we pre-sprayed ourselves with Dawn dish soap, pre-sprayed our trekking poles, our wading boots, everything. we go do work, and we were wading through poison ivy for weeks. And before people got back in my truck, I sprayed them off, sprayed off boots. Nobody got a single speck. So if you guys are allergic to poison ivy, get a spray bottle with water and Dawn dish soap, and it's absolutely life changing. And it's a whole lot cheaper than buying Technu, because that stuff hardly works. So either way. But thank you all. If you guys have questions, you can ask them now, and I'm also, I have my table. Thank you.
Thank you, Brett. We're gonna break now for lunch, and then